Everyone, sorry I'm not there to be with you today, but we're going to go through lesson 4.4. This should be a very quick and easy lesson. There's not a whole lot to this one. Alright, so we're talking about congruence for mostly today. So remember that shapes that are congruent, especially when I'm talking about triangles, have exactly the same angles and lengths. Now we've talked about some transformations. We talked about translations. That's when I slide it up, down, left, and right. We talked about some rotations, rotating it around a point. And then we've also talked about reflections. Well, we also said that all of those are called static transformations, meaning they don't actually change the size of my shape. So even though I can do all those transformations to a shape, the new shape would be congruent to the original because the shape wouldn't change size. It just changes position and how its direction is pointed. So let's look at this up here and let's think which of these shapes are congruent. Well, let's start off with our squares. I know it's a square because it's 2, 2, 2, and 2. You have a size of 2. Well, up here I have another square that all have side lengths of 2. Well, because they all have side lengths of 2 and they are 90-degree angles, these two squares are congruent. Let's look at these two triangles. Well, it has a side length of 3, a side length of 2, and then combine those there. 3, 2, combine them, and a 90-degree angle. So I know that these are congruent. They are reflected about the x-axis, and I didn't talk about these squares. The squares, the transformation that goes from this square to that square is I would shift it up 1, 2, 3, 4, 5, 6 units, and right 2. And then lastly, these triangles. Well, I have a side length of 2, a side length of 2, another side of 2, another side of 2, and a 90-degree angle. So these two triangles are also congruent. How I get from here to here is reflecting about the line y equals negative x. Okay, so there's our square, there's the triangle KLM, those two, and there are these. Oh, it says it's a 180. I could rotate this 180 degrees, and it's the same as reflecting about the line y equals negative x. Alright, here's another one. So go ahead and pause the video, try this one on your own, and whenever you think you have the correct answer, push play. Also, as you're figuring out which shapes are congruent, think about what transformations are applied to one to make the other. Alright, so go ahead and pause the video and give it a shot. Alright, so let's see here. These two, maybe the most obvious, these two triangles are congruent, and the transformation is they're reflected about the y-axis. These two rectangles are congruent. The transformation is that there has been shifted up 1, 2, 3, 4, 5, 6 units. And then these two triangles, this one and this one, are congruent, and I see this looks like it's a rotation of 90 degrees. So let's see here. Rotation, oh, it just put them all in one. So yep, so those are transformations. And then it says, well, how could I get from ABCD to EFGH? And the order of letters is important, so A is going to come to this one. So this letter A has to end up being that letter E, because A comes first. So how can I go from here to there? Well, it's flipped, so for A to come to that point, I need to first flip this about the y-axis. So I'm going to reflect it about the y-axis. If I reflect it about the y-axis, A is going to end up being right there. Well, then I need A to drop down 1, 2, 3, 4 points. So my congruence transformation would be a reflection about the y-axis, and then a translation down 1, 2, 3, 4 points, 4 units. So it says they reflected it about the y-axis and then shifted it down, or translation, down 4 units. Alright, let's look at number 3 down here. It says, well, how do I get from JKL to MNP? And so again, J and M, they're the first letters, so those two letters correspond. That point has to go there. Well, starting here, to go from here to here, I need to flip it down. So I'm going to reflect about the x-axis. If I reflect about the x-axis, this point J is going to come down here. And after I reflect about the x-axis, I need that point J to slide to the right. I need it to slide 1, 2, 3, 4, 5 units. So I need it to flex down and then slide right 5 units. So a reflection into the x-axis followed by a translation 5 units right. Alright, this is very wordy, but all it really says is that I have something and I'm reflecting it twice. And I have these two parallel lines that I'm reflecting about. And it says that when I do that, I end up with perpendicular lines here. That doesn't make a huge difference to us, but what does matter is whatever this distance is from those two parallel lines, whatever that distance is, if I want to know what's the distance from when I'm reflecting to the very last one, I just multiply that distance by 2. That's where that 2D is right there. Alright, so right here, does it tell me? Now we'll go to the next one. There we go, right here. So it tells me that the distance from line K to M is 1.6 centimeters. Okay, so I want to look at this one right here. What's the distance from P, this one, oops, what's the distance from here to here? Well, if the distance from here to here is going to be this distance times 2. Well, 1.6 times 2, 3.2. 1.6 times 2, 3.2. And it says, well, how would I get from just the blue one straight to the green one? Well, obviously, they reflect about the line K to get the red one, and then reflect about the line M to get the green one. But if I wanted to skip that one in the middle, if I just want to go straight from blue to green, I could translate right 3.2 centimeters, because the distance between here to here is 3.2 centimeters. I get that by taking the distance between the two lines, multiplying by 2. Alright, if I'm rotating, that still works. So I say rotating, I'm reflecting about a line, reflecting about another line that has an angle, so it's going to be rotating. So whatever that angle is, I multiply it by 2 to get the angle from the beginning to the end. And if that looks really weird, let's do an example. So we have these, looks like fish looking things. Anyway, so they take our blue fish, they reflect it over the line K to make the red fish. Then they take the red fish and they reflect it over the line M to make the green fish. And they said, okay, well that's great, but how could I go straight from blue to green? Well, I could go straight from blue to green by rotating around this point right here. Oops, didn't mean to do that. And by rotating, well, this angle 70 degrees. Well, what is 70 times 2? Well, 70 times 2 is 140. So I could go straight from blue to green by rotating 140 degrees. There we go. Now we'll click it. 2 times 70, 140 degrees. So a single transformation that gets me from blue to green is rotating 140 degrees. Alright, try this one yourself. Here's a blue, red, and green. They reflect, then reflect. there's my angle, what transformation would get me straight from blue to green? Go ahead and pause the video and see if you can figure it out. Alright, well, to go straight from blue to green, it's because this one's 80, I need to do 80 times 2 and get 160. 160 would get me from here to here. Number 8 is a little bit backwards. It says, well, let's say that 76 degrees is the overall rotation that gets me from this C to this C, from C to C prime. And we know that to get from C to C prime, we can use 2 reflections. Okay, so there's some shape in the middle. What is the angle formed by those lines? Well, I got to go backwards. So instead of multiplying this by 2, I divide it by 2. Well, 76 divided by 2, 70 divided by 2 is 35. 6 divided by 2 is 3. Add them together, 38 degrees. 76 divided by 2, 38 degrees gives me that transformation. And that's it. Alright, told you I was going to be short and sweet to the point. So there you go. Good luck, and I will see y'all tomorrow.